Hi, I'm Kayla. In this video, I'm going to go over 4 triangles and show you how to know whether to choose sine, cos, or tan in the SOH formula. So first, let's assume that we know enough at this point to identify that each of these triangles can be solved using SOH. If you're still not sure on whether to use that or Pythagorean theorem, see the other video. So let's look at this first triangle here. We always want to ask ourselves, what are the known and what are the unknowns? And a known is also considered a given. So looking at this one here, the first one, we are given 2 sides and we're asked for an angle. So now I want to look at my formulas and say, okay, I know this is SOH because I have sides and angles. I need to figure out which one I'm going to use. Now, the SOH, what it stands for is that the first one saying that sine is equal to opposite over hypotenuse, the second one saying cos is equal to adjacent over hypotenuse, and the last one saying tan is equal to opposite over adjacent. But for each of these, there's something very important, and that is the angle. So it's not just that sine is equal to over h, it's that the sine of the angle is equal to over h. And that's what determines what the opposite is and what the adjacent is. So let's look at this first one. If we're solving for this particular angle, I'm calling it theta. If we're solving for this angle, then the hypotenuse is always across from the right angle of the triangle. However, the opposite and the adjacent depend completely on what angle you're looking at. So we're doing the sine, cos, or tan of an angle. So the opposite and adjacent are of that angle. So if I'm looking at this theta, then 24 is an opposite side, and 32 is an adjacent side. So now, to choose which one we want to use, we have to say, which one of these, when I pick it, will give me only one unknown in my equation. So let's write this out for each one. So we want to make sure we include theta because that's what we're looking for. So if the equation doesn't include what we're trying to solve, it's definitely not the right one. So sine of theta is equal to the opposite over the hypotenuse. The cos of theta is equal to the adjacent 32 over the hypotenuse. The tan of theta is equal to the opposite 24 over the 32. Now if you're on a test and you're completely confused, write out all 3. If you have no idea, write out all 3 and then say, which one can I solve for? So you should be able to solve for one of these. If you can't solve for any, then you shouldn't be using SOH or you're using it incorrectly. Look at the first one. Is it possible to isolate for the theta angle? Remember, theta is unknown. It's not because I have this h here. Looking at the second one, can I rearrange and in some way solve for theta? No, because again, I have this h, and what the h is an unknown. So I have an unknown theta and an unknown side. I can't possibly isolate for one variable. Now the last one is great because my unknown is theta and I have 24 over 32, which is great because now I have just one unknown and I can very easily rearrange this by taking the tan inverse. So the inverse is what takes tan away from the angle and moves it to the other side. And that would solve for that angle. Okay, let's look at the next 3 triangles, and this one I'll go through a lot faster. So here we are again. We need to solve for this. We know that this side is of course hypotenuse. I need to pick one that's going to give me what I need to solve. So looking at this, I'm solving for theta. So again, this is going to be tan theta is equal to O over A. But in this case, the 20 is the O and the 13 is the adjacent side. Okay, so I picked this again because this is a triangle of the exact same shape. But notice now that the opposite is on the bottom side as compared to before, the bottom side was the adjacent. So we see that the opposite and adjacent depend completely on what angle you're looking for. Because I was solving for theta, I have to look across from theta to find the opposite. So again, the answer would be this. Okay. Alright, I'm just going to erase that previous answer so I can do number 3. Alright, so number 3 is good because we're looking for a side rather than looking for an angle like previously. So in this case, my givens or my knowns are this side here and this angle. Now I'm looking for this one. I can go right ahead and say that's hypotenuse because it's opposite from the 90-degree angle. But I need to figure out now which one I'm going to use that's going to allow me to solve for that. The first thing I say is that because 40 degrees is what I know, that is going to be my theta or my angle. But which one of these do I want to use that with? So if I'm looking at 40 degrees, 12 is the adjacent. So because I know 40 degrees and I know the adjacent and I'm looking for the hypotenuse, I need something that has A and H. And cos does. So that's what I'm going to use, and I know this is right because looking at this, the 40 degrees is a known, the 12 is a known, and the x is my unknown. So because I only have one unknown, I can solve. So if you want to do this in a couple steps, your first step would be to move x over to the left by multiplying it. And don't ever separate the cos and the 40 degrees from each other unless you're doing cos inverse. So never leave just a random cos hanging around with no angle. Doesn't make sense. Okay, and then finally you ask yourself, how is x attached to cos? It's attached to multiplication. By the way, cos is not attached to 40 degrees by multiplication. That's not right. So to get rid of this x, we can divide on the right side. Okay, so doing that will give you your final answer. One more triangle to go. We'll go through this one faster. So my known is 30 degrees. I'm using TOA. I need to figure out what side x is. It's opposite. What is 20? My given is the hypotenuse. And then since I'm looking for O, I have H, and I have an angle, I'm going to pick sine. This 20 comes over here, becomes 20 times the sine of 30 degrees. That's your final answer. Okay, so that's it for this video. Thanks for watching. I'll do another one on both non-right angle triangles and then how to solve using Pythagorean theorem for SOH or just all the angles together.